Measures of location and spread, the standard deviation for ungrouped data. The standard deviation is a measure of how spread out data is from the mean, and for a population the standard deviation uses this Greek symbol. This is lowercase sigma. In this example, data set A, which is made up of these three values, has a mean of 100, and we can see that the values are very close to the mean. Now data set B also has three values, and their mean is the same as before, it's 100, but we can see that the data values now are really far away from the mean value, so the mean alone is insufficient to try and summarize a set of data. We need to look at a measure of spread as well as a measure of average. So here I have data represented by the variable x. Here are my data values. I have 6 data values. I've worked out their mean. I'm looking at the deviation of every single data value from the mean. So I'm doing this, data value minus the mean, to get these numbers. So 3, which is x, minus the mean, which is 5, minus 2. 4 minus 5 minus 1, 6 minus 5, 1, and so on. And now I'm going to work out the average deviation from the mean. So I'm adding up all of these values, and I'm going to divide by 6. So I've added them up, but the sum of those values is equal to 0. And irrespective of the data that we start with, if we follow this method, every time we add up these values, we will always get 0, because the positive and negative values here are cancelling out. But we still want a meaningful measure of how spread the data is from the mean. So that was the data minus the mean, hence working this out. There is a workaround, and the workaround involves avoiding these negative values. So at this stage we'll do the data value minus the mean, but then we'll square all of these, hence avoiding any negative values. So that's what I've done here. So as an example, 7 is my data value, 5 is my mean, so I've done 7 minus 5, this part, and then I square that value. So 7 minus 5 is 2, I've squared that, I've got 4. This one here, I've got 3, 3 minus 5, minus 2 squared gives 4. So all of these values now are positive values because I'm squaring. And then I divide by n, where n was 6, there were 6 data values. What we've done here, this calculation and this value here, is called the variance. And because we squared earlier on, if we now square root, so if I square root my value here, so I'm square rooting this formula to get this is called the standard deviation formula. So this 2.16 is a measure of how dispersed these data values are from this mean. Now for exam purposes, you do not need to know that these values here all added up to 0 and that was a problem, and then we squared them to get these values. You don't need to know that. What you do need to know is what the standard deviation stands for, spread of the data from the mean, and you need to know the formula for the standard deviation and variance. The formula is given in the formula book. You need to know how to use this, how to rearrange the formula to work out certain values, and so on. So here's the formula for standard deviation, the one that we just used. This is the long version of it. Now algebraically it can be shown that you can also work out the standard deviation using this formula. And this one is quicker when doing calculations, because all we're doing here is we're taking on individual data values and we're squaring them. Here we had to take every single data value and subtract the mean from it first, and that was a longer process. So this formula is quicker to work with when you're doing all the calculations without use of your calculator.